Today we're going to start our second unit, and we're starting with derivatives and tangent lines. We're going to be defining what a derivative is today and also looking at tangent lines. So let's go ahead and look at this, okay? And let's just think basic, back from middle school, okay? How do I find the slope of this line? Well, we would do, and think about this. This is the point x1, y1. This is the point x2, y2. So think about the formula. M equals y2 minus y1 over x2 minus x1. Okay, so do we all agree that is the slope of this line? Okay, and also remember back, it was rise over run. Okay, so we put the y over the x's. All right, now let's change, and let's think about this next notation right here. Okay, what if I have this notation? I did it a little bit differently than I had right here. Remember, delta x means change in x. So basically what I'm adding to x1, all right, to get this. All right, so let's think about the same slope formula. It would be f of x1 plus delta x minus f of x1 over x1 plus delta x minus x1. Well, if you actually notice this for a second, these two are going to cancel. So basically the notation is f of x1 plus delta x minus f of x1 over just the change in x. Now, the problem is not all the time are our lines going to be straight. So here I have a curve right here. If I would draw in this line, okay, I could get the slope of that secant line at that point. But let's think about this. What if I were to change my delta x and I make it smaller? Okay, and I make it smaller here. And then I ultimately make it smaller here to where it is a tangent line. Where did delta x just go to? Okay, when it's a tangent line, just recall, and I know it's hard to see, tangent line means it rubs up right against right there and only touches once. So this would be as delta x basically goes to 0. The line becomes a tangent line and touches the graph at one point. Now, how do we do this using calculus? Well, think about our limits. Okay, as we get this, as delta x went closer and closer to 0, we end up with this tangent line at this point on the graph where delta x goes to 0. Well, that's just the limit as delta x goes to 0 of f of x1 plus delta x minus f of x1 over delta x. So we're going to use this formula right here to find some of these slopes. And we'll define what this is in a little bit, but for right now, we're just going to find this. Okay, just be careful. We're going to use this formula right here. So we're going to do the limit and keep your limit notation, otherwise you do get taken off. All right, and notice that this x1 plus delta x actually goes in there for that x to begin with. All right, so it's 2 times x1 plus delta x minus 3. And now we're going to do minus, all right, you got to put parentheses or brackets. And just x1 goes in there. And if you just want to use x instead of x1, you are welcome to. Okay, over the delta x. All right, let's simplify it. Keep your limit notation. So this is 2x plus 2 delta x minus 3. And I'm going to change this so it's 2, 1 up here. Okay. And then I'm going to have to distribute this negative side, negative 2x plus 3. Well, here we can go ahead and start reducing. The 3's go away. The negative 2x and 2x goes away. So here I'm left with 2 delta x. So I'm left with 2 delta x over delta x. Well, what happens there? The delta x's go away. And this is 2. All right, so here we want to know what the slope is of the graph of 2x minus 3 at the point 2, 1. Well, I don't have any x's here to plug this x into, so the slope at 2, 1 on f of x equals 2x minus 3 is 2. It's just that constant of 2. Okay, let's do this again. We're going to use that same limit notation. If you need to rewrite it again, here it is. Sometimes instead of delta x, you will see them use h. It just depends on your book. All right, I'm just going to keep with delta x, but realize, again, you may see h instead. Okay, so here we go. We're going to do the limit as delta x goes to 0. We're plugging in x plus delta x for that x, so it's going to be x plus delta x squared, and then plus 1 minus, now make sure you put parentheses around x squared plus 1, all over delta x. And now we need to simplify that numerator. All right, that's going to make x squared plus 2x delta x. All right, plus delta x squared. All right, plus that 1, and then distribute your negative, so negative x squared minus 1 all over delta x. All right, if I go and reduce, the 1's go away, and the negative x squared and x squared goes away. So I'm left with the limit as delta x goes to 0 of 2x delta x plus delta x squared over delta x. All right, here you'll notice that a delta x factors out of everything. All right, and if you actually want to see it factored, here it is. And we notice that the delta x in the numerator and denominator cancel. So let's think about this for a second. As delta x goes to 0, this part's going to go to 0. We're just left with 2x. So this is the slope. And we want to find the slope at these 2 points. The slope at 0, 1, well here, if it's 2x, you're going to have to plug in the x value. All right, would be 0. And then at the point negative 1, 2, what's the slope? Well, we're going to plug in that x value of negative 1 into 2x. So negative 1 is negative 2. So the tangent line at the point 0, 1 on this graph is at 0. And then the tangent line at negative 1, 2 is at negative 2. And if you actually look at a graph of x squared plus 1, let's let it make sense. Okay, at the point 0, 1 is actually the vertex right there. Well, that's tangent, and therefore that tangent line is right there. Okay, and it is, look, the slope is 0. It's a horizontal line. And then if I go to the point negative 1, 2, and so what I can do is I can say second trace, and I go to the value at negative 1 just to find the point. Okay, and so if I drew that line in there, think about it for a second, it's tangent, that line's going to have a slope of negative 2. So that's what that means right there, as far as slope of a tangent line. Okay, moving right along. The definition of a tangent line to a curve does not cover the possibility of a vertical tangent line. If this is the case, the limit goes to infinity or negative infinity. Okay, just to kind of let you know that right there. So it doesn't cover this case where the tangent line is actually vertical. All right, now, what is this that we're doing? All this is the definition of derivative. Okay, all that is definition of derivative. Okay, it is also the slope of the tangent line. If they ever say write an equation of a tangent line, you have to have the slope. So we're using this definition right now. And this is provided that the limit exists. All right, so here we go. You're going to also come across notation. So just make a note, freeze this. This is y prime. Okay, these are actually the terminology out to it. F prime. Okay, sometimes you'll see f prime of x. dy dx, this is derivative of y with respect to x. df dx, derivative of f with respect to x. And this means the derivative of f at x. So all of this notation could mean to find the derivative. So if you said find any one of those, then that means derivative. And you'll get used to this notation as we go along. So let's do this again. We're going to find the derivative, okay? Instead of it saying find the slope, we're doing the same thing. So again, recall the limit as delta x. And if you want to use h instead, feel free to. Okay, so I'm going to plug it in. The limit as delta x goes to 0, we're plugging this in for x. So it's going to be the square root of x plus delta x minus f of x is the square root of x all over delta x. Now, what did we do last unit when we had limits like this? We wanted to rationalize the numerator. So what I'm going to do is multiply by this right here, top and bottom. Okay, remember when we're multiplying by the conjugate, multiply the fronts, that leaves us with x plus delta x. Multiply the last. The middles all cancel out, so this just makes negative x over delta x. And then you still have that in the bottom. Okay, well you'll notice the x's cancel. Also, you're going to notice the delta x and delta x divide out. So what I'm going to be left with is delta x goes to 0. This just leaves me with a 1 in the numerator. And then this in the denominator. Now, recall delta x is going to 0. So when it's going to 0, I'm left with the square root of x plus the square root of x. Well, what is that? 1 over 2 square roots of x. I want you to realize in this, we can also use rational exponents. Remember, and you're going to see us use rational exponents a lot. You can change that to 1/2. You can also do this right here and bring it up. So just recall all these mean the same thing. All right. So again, we're doing the same thing here, f prime of x. So let's do it again. If you need to, I want you to freeze it and I want you to try some of this on your own. I'm going to go ahead and plug in x plus delta x right here. Make sure everything's mathematically correct. You'll notice 3x squared and negative 3x squared goes away. But in everything, a delta x actually divides out. okay, and I'm going to be left with, in the numerator, 2 plus delta x. And you know what? I left out an x right there and right there. So this is actually going to be a 2x all over this delta x. And the delta x divides out. And now think, what happens? As delta x goes to 0, this goes to 2x. So the derivative of 3x squared must be, and you know what? I did something wrong. What did I do wrong? I did not distribute this 3 here. So this is 6. See if you make that mistake. I do make mistakes. It's okay, and hopefully I get it all corrected. So when I go back, this is really 6x plus 3 delta x, and here this part's going to go to 0, and we're going to be left with 6x. So be careful when you have to distribute. Don't forget. Okay, a little more extension. Find the slope of a parabola, y equals x squared, at 2, 4. Write an equation for the tangent line. Well, remember when I recalled this form right here, point slope form? Well, we're going to use that, and I'm going to write the tangent line. But the first off, I have to have a slope. That's where we do the limit as delta x goes to 0. So here we go, x plus delta x squared minus x squared all over delta x. Notice again, I forgot that x right there. I'm trying to do this from memory and then I mess up. Okay, so there's the 2x. All right, and here the delta x divides out, so I'm left with just 2x as this goes to 0. All right, so now I have to find, I'm looking at the point 2, 4. So find the slope at 2, 4. So it's going to be 2 times 2 equals 4. So this is going to be the slope right here. And now I just need to plug in the point 2, 4. y1 is 4. The slope we said was 4. And then x1 is 2. So here's the slope of the tangent line at that point. Now, I did something I shouldn't have done. In calculus, we don't want to box our answers. Okay, because if for some reason we go too far on a problem and they say that's the answer, but you've boxed the wrong thing, they're going to take off. Okay. However, if you go too far and you don't box, they're just going to stop where you are, where the answer is, and not worry about where you went too far. So do not make that mistake. All right, now find the slope of the curve. So here we go. Stop the video and you start doing it, or just look up when you're done. Now, for this right here, we really haven't seen anything like this, but remember, we want to get all these fractions out of there. If you want to multiply by a common denominator, the whole thing, x and then x plus delta x in the numerator and denominator. Okay, think about when you distribute. When you distribute here, okay, the x plus delta x goes away. All right, and you're just left with x. When you distribute here, okay, the x's go away, but I'm going to be left with minus, you got to have your parentheses, x plus delta x all over. Okay, and then here you're still doing it, so times x and then x plus delta x. Don't multiply any of that out, and it's going to work its way out. Here, remember this is a minus, so we can distribute, and look, the x's actually go away. Now this is going to be the limit as delta x goes to 0. Now notice delta x's are going to cancel, but I'm going to still have that negative 1 up top. All right, and then as delta x go to 0, that goes to 0, and I'm left with negative 1, and then x times x, which is negative 1 x squared. And this can also be written as negative x to the negative 2. I want you to just know that as well. So we found the slope at the curve. Now, where does the slope equal negative 1/4? So, where does this negative 1 over x squared equal negative 1/4? Well, here the negatives can cancel out. And if you want to think of this as a proportion, you can. You end up with x squared equaling 4. And when we take the square root, what do you need to know about square root? Plus or minus. So x equals plus or minus 2. So where does the slope equal to negative 4? Both at positive and negative 2. Okay, on the graph of f of x equals 1 over x. This is part 1 of this lesson. Stay tuned. There is a second video.